This is question number 2 of 1000. And today the question tells us equations, and we need to find the partial derivative of w with respect to theta when the r is 2 and theta is pi over 2. So w is xy plus yz plus zx. X in this case is r cos theta, y is r sin theta, and z is r theta. Now we can plug all these values in this equation and then take the derivative. But today, let's use the chain rule of multivariable calculus to solve this equation. So using the multivariable chain rule, we get that partial of w with respect to theta is partial of w with respect to x times x with respect to theta plus partial of w with respect to y times partial of y with respect to theta plus partial of w with respect to z times z with respect to theta. Now let's find all these partials and plug it in the equation. So to find the partial of w with respect to x, we're going to look at our first equation and treat every other variable other than x as a constant. So the derivative of xy with respect to x is y, plus derivative of yz with respect to x is 0 because this is just a constant, plus zx with respect to x is z. So now to find the partial of x with respect to theta, we're going to look at our second equation and treat every other variable other than theta as a constant. So r in this case is constant because we're finding the derivative with respect to theta. So we get the derivative of r cos theta with respect to theta is just r times negative sine theta. And similarly, we can find the partial of w with respect to y, which is x plus z, partial of y with respect to theta, which is r cos theta, partial of w with respect to z, which is y plus x, and partial of z with respect to theta, which is r. And we get the partial of w with respect to theta is y plus z times negative r sine theta plus x plus z times r cos theta plus y plus x plus r. Now remember, from our initial equations, x was r cos theta, y was r sin theta, and z was r times theta. Now we're finding the value for partial of w with respect to theta when r is 2 and theta is pi over 2. When r is 2 and theta is pi over 2, x becomes 2 cos pi over 2, which is 0. Y becomes 2 times sin pi over 2, which is 2. And z becomes 2 times pi over 2, which is pi. Now let's plug in all these values in our equation, which is equal to negative 4 minus 2 pi plus 4. Negative 4 and plus 4 cancels out, and we get that the partial of w with respect to theta is equal to negative 2 pi.